Evaporative cooling, either by industrial evaporative cooler, the pad coolers, or air misting at the open spaces, and how to relate that with psychometric chart and stack data for the design that is particularly important to learn. Very interesting. Obviously, evaporative cooling is more efficient where places with low humidity because the difference between dry bulb and wet bulb is higher, and water at the wet bulb, the temperature is very low comparing with the dry bulb, and that gives you a kind of comfort and better evaporative cooling. For instance, if we take the data of Medina, my ideal scenario at Saudi Arabia, at 0.4% probability, we have wet bulb 72.4 degree Fahrenheit, and dry bulb is 98.9 degree Fahrenheit. If you see closely, the difference between wet bulb and dry bulb is very high. And that's why I said you earlier, the higher the difference is, the better evaporative cooling you are going to get. Let's go to our favorite psychometric chart from the ASHRAE. What we have is dry bulb 98.9 degree Fahrenheit and wet bulb 72.4 degree Fahrenheit. We plotted it here. Number 1 point, the dry bulb and the wet bulb. Now, as we spray the water temperature is at the wet bulb 72.4 degree Fahrenheit. And as we directly spray this water in the air, the sensible heat of the wet bulb, it tends to react first and take the temperature down. Now, if you see the difference, 98.9 and 72.6 degree Fahrenheit, and multiply with the experimental coefficient of efficiency 0.4545% is 11.8 degree Fahrenheit. So if we spray instantly, the temperature is going to be 98.9, the dye bulb, minus 11.8 is 87.1 degree Fahrenheit. Here, the temperature is going down now. So this directly acting and taking down the temperature. And finally, as we are spraying the water, air is cooling down and the wet bulb temperature is also changing. Here, another scenario in this particular position, 87.1 degree Fahrenheit is a dry bulb now, the change scenario, and wet bulb in this particular scenario is 69 degree Fahrenheit now. See, earlier the wet bulb was 72.6 degree Fahrenheit, now it is 69 degree Fahrenheit. Since we have sprayed the water and at the indirect cooling, we are going to have some advantages. Again, if you continue to spray the water in this particular scenario, directly the evaporative cooling is going to react. Now, 87.1 degree Fahrenheit is your dry bulb temperature at this change scenario, and the wet bulb is 69 degree Fahrenheit. You take the difference, multiply with the experimental coefficient of efficiency 0.85, and what we get is 15.38 degree Fahrenheit, the difference. So the temperature, the dry bulb is further going to be lowered to 87.1 minus 15.38 is 71.72 degree Fahrenheit. And finally, you reach to this point. And at the change scenario here, what we have is the dry bulb 71.72 degree Fahrenheit and the changed wet bulb is 69 degree Fahrenheit. See, humidity also increased. Evaporative cooling is particularly efficient in open spaces. If we continuously do evaporative cooling in closed spaces, spaces that not so big, not like warehouse, In a very small space, if we do evaporative cooling, the weather is going to be hot and muggy. Sometimes it is unbearable. Again, you need to check this with SC55, the human comfort zone. However, evaporative cooling is more efficient in large space and in open space, obviously. So good luck in calculating uh, evaporative cooling and doing the sizing, and psychometric charts gives away all the data that you need to design a good evaporative cooling system. Let's move forward.